Hi, this is Kyung-youn Kim from National Chungcheong University. Today I will talk about my research area, which is heat corner estimate for symmetry Markov processes. First, I will start with the normal distribution. Normal distribution is the transient density of the Gaussian random variables with the exponential terms, and it is defined with the mean mu and a variance square of the sigma. So according to the value of the mean, mu, and variance, the graph is changed, but you can see that it has the very light tail. And also Brownian motion is the key element in the physics since it describes the particle in a liquid. And Einstein found that in 1905 that the transient density of the Brownian motion is the solution to the heat equation. And it is the form of the normal distribution with mean 0 and variance t. So the transient density is a key element in PDE theory as well as in probability theory. Similar to the Laplacian, related to the fractional Laplacian, there is a process which is called alpha stable processes, where alpha is in between 0 to 2. In case alpha is equal to 2, it is the Brownian motion. So you already know that the transient density of the Brownian motion has the light tail with the exponential decay. On the other hand, where alpha is in between 0 to 2, it has a very heavy tail with polynomial decay. And there are many people are curious about the exact formula of the transient density of the alpha stable processes. On the other hand, it is difficult to obtain the exact form for the transient density, but we only know upper and lower bound with the time variable and the jumping corner with the t. So I focus on this topic to get the transient density in more complicated processes or generalized process beyond the Levy. So we consider the new process Y with the jumping corner J. Alpha stable process is the typical example of the Levy process with the jumping corner this. And we generalize this jumping corner into using the function pi, which is comparable to the r to the alpha, and the function chi, which is the exponential function. Using this jumping corner, we construct Markov process Y, and we obtain upper and lower bound using the new function f. So as you can see, in case beta is larger than in certain point and x and y is larger than certain point, it has the light tail with the exponential decay. On the other hand, it has the heavy tail. So it is the first result with the process having the heavy tail and light tail together. And we also observe the upper and lower bound for the transient density in certain perspective. So you can see this is the exit distribution where x is near to the boundary. And we also consider new process, which is the non-isotopic processes. We first consider the jumping corner, which is comparable to this function, and it is defined only where only the 2 points are different, only one coordinate. And using this jumping corner, we obtained upper and lower bound for the transient density of the non-isotopic process Z, which is the product of the each coordinate. So this is the each coordinate one-dimensional processes, and the heat corner is product of them. So this is the first result for the non-isotopic processes, which is pure jump processes. So we can use this approach to get the more complicated or generalized process using put some chi put here, or non-isotopic process plus the diffusion process together processes. And also we consider usual heat corner in certain open set D. if you are curious about this research area, please contact me and discuss more in detail in the conference. Thank you for your attention.